Well, hi there! Welcome to the biggest event in the history of Clint's Reptiles. The documentary that you're about to see has been over 2.5 years in the making. As such, you will observe many changes to our studio and our appearance as we take you through every family of lizards, including all the snakes, as well as their closest relatives, as we dive into the Lepidosauria to a depth that no video in the history of YouTube, and perhaps the world, ever has before. Thank you for joining us. Lepidosauria is the most diverse clade of tetrapod vertebrates on the planet, with over 12,000 known species. They range in size from the Komodo dragon, which weighs as much as a grown man, to the nano chameleon, which was just noticed in 2021 and can stand on your fingertip. From the reticulated python that occasionally eats a person, to the Barbados thread snake that can sit comfortably on a quarter. They have colonized every continent and today occupy every continent except for Antarctica. Almost all extant lepidosaurs are lizards in the order Squamata. However, there are actually two extant orders, the other being the Rhynchocephalia, which was a large and speciose order during the Mesozoic, found all over the world, but today is represented by a single species, the tuatara of New Zealand, which I had the privilege of seeing a few years back when I went to New Zealand. At a glance, they look like lizards. In fact, at one time they were classified as agamid lizards, and they are very similar. They're about the size of a bearded dragon and the shape of an Australian water dragon. They have no closer extant relatives than lizards, but there are some key differences. For one thing, tuataras have gastralia, like crocodilians and dinosaurs. Gastralia are dermal bones on the bellies of tuataras and many other reptiles between the sternum and the pelvis. The turtle bottom shell, called the plastron, is made largely of the gastralia. So it isn't really strange that tuataras have them. It's more of interest that they've been lost in the squamates. Another feature that tuataras have that is not strange is a portion of the skull right here, the lower temporal bar. Lepidosaurs and all other extant reptiles are part of the clade Diapsida in reference to these two holes on each side of the head behind the eye, the post-orbital or temporal fenestrae, which serve to lighten the skull and allow for larger jaw muscles. You can see them right here on this alligator, or here on this Deinonychus, and right here on this tuatara. All good diapsids, but squamates have lost this lower temporal bar. The lower temporal bar is made up of two bones, the jugal bone and the quadratojugal bone. But squamates are lacking the quadratojugal bone entirely. So they don't have a lower temporal bar. And their lower temporal fenestra is more of a rainbow than a hole, which actually seems to be a shared trait among lepidosaurs, including rhynchocephalians, but appears to have been re-evolved within the tuatara subfamily Sphenodontidae. They have two rows of teeth on the top jaw and only one on the bottom, and a beak-like structure at the front formed by the fusion of their premaxillary teeth, a bit like a pufferfish, which is a common feature of rhynchocephalians, but something not found in the squamates. So that's a few things that tuataras have that lizards do not. But there are a few things that lizards have that tuataras do not. And yes, one of them is a penis, or rather two penises, but I'll start with the ears. Tuataras have no external ears. Of course, neither do chameleons, snakes, and many other lizards that we'll discuss later. They do hear, but they have no external ear openings. And so I guess we're back to talking about penises. Squamates have two penises, called hemipenes. Tuataras do not. They transfer sperm to the female via a cloacal kiss, more like a bird. And while we're on the subject of cloacas, let's talk about some of the conspicuous similarities between tuataras and lizards. I'll start with a transverse cloacal slit, often called a vent, like this, and not like this. They also have fracture planes in the tail vertebrae, allowing the tail to be voluntarily dropped, autotomized. as well as shedding the skin altogether and not scale by scale. And also, like squamates, those scales tend to overlap one another. And surprisingly, probably the most notoriously unique feature of tuataras, their third eye, called a parietal or pineal eye, is also something that they share with many squamates, as well as other tetrapods such as frogs. So it's super famous in tuataras, but not even unique to reptiles. That said, I'll still discuss it here because it is such a famous attribute of tuataras, and it is more pronounced than it is in other extant vertebrates. So I'll start with what this third eye is not. It's not an eye. At least not the same kind of eye as the two eyes that tuataras and most other vertebrates possess. It's more like the eye spots on a planarian, and it performs a very different role, but a very important role. I've heard many people claim that the pineal or parietal eye is there to detect shadows of predators. And I can tell you, if you haven't noticed a predator until you're in its shadow, you're probably about to die. That said, they do have receptors for motion and detecting approaching predators. Those receptors are called their eyes. So they can do this, just not with the parietal eye. The pineal gland is the gland that produces melatonin. It forms part of the epithalamus of the brain. Now, if you're familiar with melatonin, you've either taken a lot of biology or you struggle with sleep, because melatonin regulates sleep patterns. And that's going to be your first window into what this pineal eye does. The pineal eye is basically an outpocket of the pineal gland that protrudes through the skull through a hole in the parietal bones called the parietal or pineal foramen. So you can probably see why it's called both the parietal eye for the bones and the pineal eye for the gland involved. It is most visible in hatchling tuataras. It's covered in skin, which is opaque and pigmented in adults. But it does detect light. It detects when it's night and when it's day and how long it's night and how long it's day, and essentially communicates to the animal when it should be awake and when it should be asleep and what time of year it is so that it can prepare for periods of extended sleepy time, which is important, just not for the reasons people generally think. And important to tetrapods across the board. Of course, in humans, the pineal gland is embedded deep inside the brain, inside of a thick skull covered in skin and hair. As a result, it can't detect light directly, and thus light information is transmitted to it via the eyes instead of directly. And why people who are totally blind, or who spend extended periods in near total darkness, such as deep in caves, often have difficulty regulating healthy sleep patterns. Their bodies have no idea when to dose them with melatonin. So those are the tuataras, the only species in the family Sphenodontidae, and indeed in the entire order Rhynchocephalia. A living fossil, if you will. And I'd be remiss if I didn't mention that they can live much longer than most squamates, not even reaching maturity until they're nearly a decade old. Their average lifespan seems to be upward of 60 years, with some living over a century. So they're a living fossil that lives a long time as well. And that brings us to the rest of the Lepidosauria, which all fall into the second largest of all vertebrate orders, the order Squamata. And we've already discussed what unifies squamates in some detail. But in absence of gastralia, as well as lacking a lower temporal bar, and having a pair of hemipenes, well, that'll get you on the right track. Now, I've heard it argued that snakes and another group of squamates, the amphisbaenians, are not lizards. And from a phylogenetic standpoint, that is almost impossible to defend, as we'll discuss later. But if you wanted to exclude one family of squamates from the lizards, it would be this one, the family Dibamidae. All other extant squamates are more closely related to one another than they are to the Dibamids. And Dibamids are seriously weird reptiles. I don't think anybody would argue with you if you said that they aren't lizards. I mean, what about this creature screams lizard? And yet I've never heard anyone, except for me, publicly declare them not to be lizards. I mean, they can be, but as the hagfish of lizards, if you were going to remove a single clade of squamates from the lizards, this is the only one that you could and still maintain a monophyletic lizard clade. So if you don't want lizard to be a common name for squamata, then these guys have to go. But I suspect that the reason that there isn't more call for the ouster of Dibamids from the lizards is because most people never even heard of a Dibamid. So what the heck is a Dibamid? Well, they're weird, legless or almost legless, fossorial little squamates, often called blind skinks, despite not being blind or skinks. They have tiny little eyes covered with skin, and skinks are more closely related to literally every other squamate than they are to these. There are only about 25 species of Dibamids in the whole world, and all but one species live in Southeast Asia, and the remaining species lives in northern Mexico, with the split between the two genera occurring in the late Cretaceous under the supervision of the tyrant lizard king. I say almost legless because while females are totally legless, males have tiny little flap legs for holding onto the females during mating. They are proportioned much like snakes, with a long body and a short tail. Like snakes and tuataras, among others, they have no external ear openings. Most are dark in color with limited pattern, and they fade to a lighter ventral side. And while they have eyes, they're probably limited to approximately the abilities that most people falsely attribute to the pineal eye in tuataras. Their skull is very solid and not kinetic as it is in most lepidosaurs. They do not have a parietal foramen, and thus they do not have a pineal eye. Of course, living underground, it's dark all of the time anyway, so it wouldn't be worth much if they had one. But being able to tell that it is light at least communicates to you that you're somewhere that you're probably not wanting to be if you're a Dibamid. If the Dibamids have any other close relatives among the squamates, it's probably these, the members of the clade Geckota. Though it generally appears that Geckota, while the next most distantly related clade of lizards and our next best candidates for removal from the lizards, are more closely related to all of the other squamates than they are to the Dibamids. So you could remove the Dibamids without removing the geckos. And if you want to join me in this crusade to kick the Dibamids out of the lizards, have I got the shirt for you. Yes, of course, only like 0.01% of the population will have any idea what you're talking about. But those are just the kind of people you want to talk to, am I right? We'll have a link to that down in the description. That said, you could also kick out the geckos, if you wanted to. And snakes and amphibians would still be lizards. In fact, today there are 7 families, about 125 genera, and almost 2,000 species of described geckos. This makes them one of the most speciose of all lizard groups. Geckos are generally small, ranging from less than an inch to about 2 feet in total length. Most geckos possess the ability to vocalize, which is actually very uncommon in the other lizards. And geckos are primarily nocturnal, with most possessing large eyes with vertical pupils that can dilate very wide to let in a maximal amount of light at night. In many groups, those elliptical pupils constrict into a row of tiny diamonds during the day. And interestingly, whereas most nocturnal animals possess a lot of rod cells in their eyes for excellent night vision, geckos do not possess rod cells at all. Instead, they use modified cone cells, the cells generally used for excellent daytime color vision, but not night vision. As a result, geckos have excellent color vision even at night, which may have something to do with the crazy beautiful colors seen on many geckos. All but one family possesses fused, transparent eyelids called a brill. Thus, they do not blink because, as is the case with snakes, their eyes are closed all of the time and cannot open. They often can be observed cleaning the brill with their tongues. As with snakes, the brill is shed when they shed their skin, but it is more difficult to observe because they generally eat the skin during shedding. I kept geckos for years before I first found the skin from the head of a gecko and noticed the brill. While not totally unique to geckos, nor possessed by all geckos, the toe pads possessed by the majority of geckos are frequently associated with the geckos. And these toe pads are some of the coolest structures in all of nature. They stick to things, but not because they're wet or anything like that, To understand what's going on, you're going to need to understand a bit of physics and chemistry. You see, atoms are composed of positively charged protons called a nucleus, orbited by a cloud of negatively charged electrons. When an atom has more electrons than protons, it is negatively charged. When it has more protons than electrons, it's positively charged. And when the numbers are the same, it has a neutral charge. Just like with magnets, positively charged atoms and negatively charged atoms are attracted to one another. Whereas positively charged atoms are repelled by other positively charged atoms, and the same goes with negatively charged atoms with other negatively charged atoms. But what happens with neutral atoms? Well, they are attracted to one another because the electrons in one atom are attracted to the protons in the other, and vice versa. This isn't as strong as the bond that you see between a positively charged atom and a negatively charged atom, but it will cause them to stick together if they're very close to one another. This attraction of neutral atoms, called van der Waals force, is very weak and only works when two neutral atoms are very close to one another and no stronger forces are present to pull them apart. And it was long thought that this was what was responsible for gecko toe pads adhering to objects. But now it looks like this is not the case. Instead, it looks to be due to a crazy phenomenon called contact electrification, where two objects, when they come into contact, exchange charge, resulting in one object becoming positively charged and the other negatively charged. Thus, like magnets, they attract. And this is a stronger attraction than what would be possible using only van der Waals force. Even so, it takes a heck of a magnet to hold up a whole gecko. How does that fit on those tiny toes? Well, those toes have enormous surface area. You can see the ridges with the naked eye, but covering those ridges are tiny hair-like structures called setae, which themselves are divided into numerous ends called spatulae. In other words, there is much more surface area than meets the eye, allowing enough atomic interaction between the toe and the surface they are on to hold the gecko onto the surface very easily. In fact, so much that they cannot lift their feet off, but rather need to peel their toes back like tape to lift their feet. This is crazy cool. Geckos are found on every continent except Antarctica, so if our arachnid video has you planning to move to Antarctica, don't expect to see any geckos. But today I would like to introduce you to all 7 extant gecko families, because there are almost certainly a few you have never seen before. Hey, it's that time of year again. Into the AM is gearing up for their biggest event of the year, Black Friday and Cyber Monday. And Black Friday is starting earlier than ever because starting November 13th and running all the way until December 8th, Into the AM is offering up to 60% off on their entire collection. Whether you're looking to refresh your own wardrobe or pick out some amazing holiday gifts, this is your chance to snag these eye-catching graphic tees, sleek basic tees, and cozy outerwear for the best deals of the year. I've been loving wearing Into the AM t-shirts for several months now, and look at this one with a glow-in-the-dark octopus on it. That's even cooler than the ones I've already got. And here's an extra treat just for our fans at Clint's Reptiles. Click the link in the description box below and use my code for an additional 10% off. That's on top of the huge discounts already happening, meaning that you can stack your savings and get an even better deal. So if you've been waiting for the perfect time to get an Into the AM t-shirt, click the link below and grab those deals. Happy shopping. Geckos are broken up into 2 large clades, the Pygopodoidea and the Gekomorpha. Which of these 2 is more familiar to you will largely depend on whether or not you are from somewhere near Australia. I'm not, so I'm going to start with the Gekomorpha and save the crazy Australian geckos for last. The Gekomorpha contains 4 of the 7 gecko families: the Eublephaриdae, Spherodactylidae, Phylodactylidae, and Gecconidae. In case you are not aware, family names always end with idae. And dactyl means finger or toes, as with pterodactyl, wing finger. And since geckos have such interesting fingers, you will notice that finger comes up a lot with their names. Anyway, getting back to the Gekomorpha clade, the 2 most closely related families in this clade are the Phylodactylidae and the Gecconidae. The Geckonidae is the single largest, in terms of total species, family of geckos with over 950 described species. These include some of the most widespread and iconic geckos like house geckos, tokay geckos, day geckos, and morning geckos. And what you will notice about all of these geckos is that they have a very similar body plan. These are your stereotypical geckos. They are found on every continent except Antarctica. If you find a generic-looking gecko, there's a very good chance that it's part of the Geckonidae. The Phylodactylidae are their closest relatives. Philo meaning leaf and dactyl meaning finger, these are the leaf-fingered geckos. This group includes the turnip-tailed geckos that we found in the Amazon. These, being the closest relatives of the geckonid geckos, are pretty typical-looking geckos, but most have toe pads that look like ginkgo leaves. They're also recognizable by a single codon deletion present in the genomes of the entire family, but that's difficult to spot when you see them in the jungle. These are found mostly in South America and Africa, with some expansion into North America, Europe, and Asia. And there are a little over 150 described species out there. The closest relative of these two families are the family Spherodactylidae. These are tiny geckos. In fact, they are some of the tiniest of all amniotes, which are mammals, birds, and other reptiles. The average snout vent length of these geckos is just a bit over ½ an inch, and the longest member of the entire family is just about 2½ inches snout to vent, according to research done by Hedges and Thomas and Rivas and Shargel. We found several species of these geckos in Peru, including 2 species from the genus Pseudogonatodes and an Amazon pygmy gecko, which was absolutely the smallest reptile I have ever seen. It was the size of a hatchling mourning gecko as an adult. In addition to being small, members of the family Spherodactylidae can be identified by their round pupils and toes. They lack the toe pads of most geckos. In fact, sphero means spherical, and dactyl still means finger, so these are the spherical or round-fingered geckos. Though tiny padless round-pupiled geckos would work as well. There are about 200 described species, and they are found primarily in South America, but also in North America, Asia, Africa, and Europe. And the last family in this clade, the most distantly related to the other 3 families, are the Eublephaриdae. This is a small family with only a little over 40 described species, but it is one that you're probably familiar with, because this family includes geckos like leopard geckos, banded geckos, fat-tailed geckos, and cave geckos. These are the eyelid geckos. Now, as we discussed earlier, geckos have eyelids, but they're generally fused shut. In the case of the eublepharid geckos, the eyelids are movable. This makes them unusual for geckos, but actually pretty normal for lizards in general. Also similar to the majority of lizards, and their cousins, the spherodactylid geckos, these guys lack the adhesive toe pads of most geckos. And that makes a lot of sense, since most of these geckos are ground-dwelling, frequently found in the more desert environments of North America, Africa, and Asia. Unlike the spherodactylid geckos, eublepharids tend to have vertical, cat-like slit pupils, and are primarily crepuscular or nocturnal. And that brings us to the other big clade of geckos, the geckos down under, the Pygopodoidea. This clade includes the remaining 3 gecko families, the Diplodactylidae, the Carphodactylidae, and the Pygopodidae. Of these 3 families, the 2 most closely related to one another are the Carphodactylidae and the Pygopodidae. And since the Pygopodidae are so outrageously strange, I think I'll start there. Now, pygo means posterior, and pod means legs. So these are the posterior-legged geckos. What does that mean? Well, it means they don't have any anterior legs. They only have hind legs. And even those are just a couple of silly flaps. That is, assuming they have any legs at all. These are legless, or very nearly legless geckos. They are one of those legless lizards that nobody seems to have any difficulty calling lizards that I referenced when we talked about the other squamates. Other than not having toe pads, or legs, they're fairly typical in terms of the other gecko features. They lay paired eggs, have fused eyelids that they lick clean, etc. But you're not going to confuse them with any other geckos. There are about 35 described species in Australia and New Guinea, and weird. Did I mention that they're weird? The closest relatives to the Pygopodidae are the Carphodactylidae geckos, which, as best I can ascertain, means withering fingered geckos. I'd guess because they have no toe pads. But I'd probably call them the strange-tailed Australian geckos, because these are primarily the knob-tailed and Australian leaf-tailed geckos. Not to be confused with the leaf-tailed geckos from Madagascar, which are in the family Geckonidae. There are fewer than 40 described species, making this the least speciose family of geckos, but in certain parts of Australia, they're very well represented. So if you're in Australia and you see a gecko with front legs, withered toes, and a weird tail of some sort, it's probably a carphodactylid gecko. And that brings us to the last family of geckos, and probably my favorite, at least from a pet keeping perspective, the family Diplodactylidae. This family includes geckos like crested geckos, gargoyle geckos, chameleon geckos, leechies, chewies, seras, the amazing New Zealand green geckos, the crazy spiny-tailed geckos that shoot sticky goo out of the spines on their tails. So many rad geckos. With over 150 species, this is the most diverse family of geckos in Australia and New Caledonia, and the only family found in New Zealand. Unlike the other Australian geckos, these do, with only one exception, possess toe pads. Often they even possess an extra adhesive pad at the end of their tails. One very unusual thing about this family is that some are viviparous, giving birth to live young. There are a couple of species from New Caledonia and all of the New Zealand species that give live birth. Now, I told you earlier that Dibamids are not skinks, and that skinks are more closely related to all other squamates than they are to Dibamids. And this is all true. But skinks, along with their closest living relatives in the clade Skinkiformata, are the next most distantly related group of squamates after the Dibamids and the Geckota. So you could kick them out too, and, well, still snakes and amphisbaenians would be lizards. But why would you want to kick out the skinks? They're probably my favorite single family of lizards, though the varanids certainly give them a run for their money. We'll talk more about them later. Skinkiformata contains 4 families in 2 clades. The skinkmorphs, Skinkimorpha, which includes only one family, Skinkidae, and the cordylidmorphs, Cordylomorpha, which contains the other 3 families. Cordylids are girdled lizards, just in case you've never heard that word before. So the skinks are actually the hagfish of the skinkform lizards. And being that they have been diverged from the other lizards for a very long time, not as long as the geckos, but a very long time, they've had a lot of time to speciate. Combine that with their very successful torpedo-like body plan, which allows them to be successful underground, in the water, on the ground, and up in trees. This has become a very speciose group with over 1,500 described species. And even given that, I can still hardly believe that emerald tree skinks actually exist. Though there are exceptions, in general, they're shaped like a torpedo with very little change in width from the back of the head to the start of the shoulders. They have fairly short limbs, with some being legless or nearly legless. Most have long, gradually tapering tails, and no skin fold on their sides, as we'll see in many similar-looking lizards. Though most skink species do lay eggs, about 45% of skinks give live birth, as is the case with the blue tongues and zebra skinks that live at Clint's Reptile Room. Some, such as the blue tongues and prehensile-tailed skinks, even have a placenta similar in function to that of most mammals. And parental care of one type or another is fairly common in this group. They're found on every lizard-possessing continent in the world, as well as most of the warmer islands in between, and range in size from about 10 centimeters, which is about 4 inches, to the placenta-possessing prehensile-tailed skinks, which are about 3/4 of a meter long. And though this is actually the first time that we've discussed the Skinkiformata, I can just about promise that we will have to make a full-length video diving deeper into just the skinks fairly soon. I just love them so much. But we still need to talk about their closest living relatives. The 3 families of girdled lizardish lizards, if we're calling anything that we have so far discussed lizards, of the clade Cordylomorpha. And are we calling these lizards? Where do we want to draw the line? Anyway, the family least closely related to the other 3 Cordylomorph families is the family Xanthusiidae, the night lizards that live right here in Utah. And they are pretty much restricted to southwestern North America and Central America. Which makes sense, because while skinks are the masters of a diverse range of habitats, night lizards, or night squamates, if we aren't considering anything that we have discussed so far to be a lizard, are the masters of small, super specific microhabitats. Which is good because they tend to be pretty small themselves, with the largest species only getting to be about the size of the smallest skinks. Some spend their entire lives under the same tree, so it isn't much of a surprise that they haven't dispersed very far. There are only 34 known species on Earth, and though they're somewhat skink-like in shape, you shouldn't confuse the two. Their tiny round scales over most of their bodies are more like those of the Lacertids that we'll discuss later, the true lizards. But you shouldn't confuse them for Lacertids either. Not only are they found in the wrong part of the world, but they have fused eyelids, like snakes and most geckos. This means that they never blink, and their eye is round, as no part is concealed by an opaque eyelid. Their eyes are always closed, but their eyelids are clear. Between the scales and the eyelids, you shouldn't confuse them with anything else. Like some skinks, they are placental and give live birth following extended gestation to a relatively small number of offspring. It's really no wonder that they haven't gotten very far. Their closest relatives are the two remaining families in this clade. The plated lizards of Africa and Madagascar in the family Gyrosauridae, and the girdled lizards of eastern and southern Africa in the family Chordilidae. And the reality is that neither of these families are very large. There are fewer than 40 species of plated lizards and fewer than 70 species of girdled lizards. Both of these families are heavily armored, and while forelegs are typical of both groups, you get legless or nearly legless species in both families. Girdled lizards tend to have a somewhat pointed snout that is considerably narrower at the tip than it is at the base, whereas plated lizards have a more rounded snout, a bit more reminiscent of skinks. Girdled lizards are often more flattened and lizard-shaped, whereas plated lizards are very skink-shaped. But again, these are just generalities. Both of them come snake-shaped as well. And while some girdled lizards can roll into a ball of spikes, that's not typical of the group as a whole. And that brings us to the lizards. Welcome to the Laterata, one of the strangest clades of lizards on the planet. And I say lizards with such trepidation because while this looks like a lizard and this looks like a lizard, most of the clade is made up of creatures that look more like annelid worms than they do like lizards, or even reptiles. And if you go to Wikipedia, which has been demonstrated in the sciences to be more accurate than the average college textbook, and you search for Squamata, the group that includes all of the lizards, it says, Squamata, scaled reptiles, is the order of reptiles which includes lizards and snakes and the Amphisbaenia. You're probably familiar with lizards. Here's a video about all of the snakes, but what is an Amphisbaenian? Well, it's what these are. And I don't know about you, but if I told you that I was going to talk about a group that includes humans and Will and Jason, I mean, wouldn't that give you reason to suspect that whatever Will and Jason are, they're not humans? So whatever these are, they aren't lizards. They're something else. But what about Gus Gus? Well, Gus Gus too is part of the Laterata. So is he not a lizard either? Well, let's dive into the Laterata and find out what they are, how to recognize them, and how to tell them apart. And we'll start with Gus Gus here, since he's about the greatest thing on the planet. And we'll start by looking at his belly. See these bands of rectangular scales? Flip over lizards from any other group, like this bearded dragon, or this gecko, or this monitor lizard. Do you see anything like that? You see the same basic scale pattern forming bands around the tail. And you're gonna notice the same basic pattern on all of the members of this group. These tile-like scales are actually the reason for the group name, Laterata. The Laterata is made up of two big clades, the Tiaformata, the Tiid-form Lateratans, and the Lacertabaenia, which pleases me to no end since it contains Lacertas and Amphisbaenians. And I love it when they just smash names together like Benifer, Brangelina, Kimye, or Swelsey. And we'll get to them, but I want to start here with the Tiaformata. which contains 3 families: the Teiidae, for which the group is named, the Gymnophthalmidae, and the Elapoglossidae. These are all pretty big families. I mean, most people, even reptile people, have probably never heard of Gymnophthalmids, but there are over 250 species. I encountered one for the first time just a couple of years ago when I was in the Peruvian Amazon. But my relationship with the Teiidae goes back far longer. Gus here, he's a Teid, but he's rather an unusual Teid, mostly because he's huge. Teids, by and large, are small to medium-sized lizards. They're generally known as whiptails or race runners, and they are impressive runners, occasionally running on 2 legs at very high speed. They can be identified by their laterata scales, combined with granular bead-like scales on their backs, forked tongues, and very distinctive head, which is tall and shaped rather like an elongated square pyramid, with large scales on the top and sides of the face, including very distinctive scales bordering the mouth. Those large scales really stand out, given especially how small the scales on their backs tend to be. It includes over 150 species, including amoebas, tegus, and caiman lizards. We did a video about some of them a few years ago, but this group clearly needs its own video. I mean, it has a bunch of parthenogenic species, as well as the only warm-blooded lizards known to exist. This one. They're found all over the Americas, a place where monitor lizards do not exist. But they are, as a group, highly active, intelligent, fork-tongued little lizards. And in a world without monitor lizards, this left the niche of active, intelligent, fork-tongued, big lizards wide open. And which group filled that niche? This one. Male tegus, like Gus here, also have possibly the strongest bite of any lizard, upward of 1,000 newtons, though I'm yet to find a number from a source I really trust. That is more than a pit bull dog. And though I'm still looking for a better source on that number, I have felt the power of these jaws firsthand, and 1,000 newtons seems about right to me. Though I've seen some places claiming sky-high numbers for Komodo dragons, it appears that the real number may only be around a quarter of that of the tegu. Like a crocodilian, they use the power of the muscles in their necks to greatly increase closing pressure. And these muscles in male tegus are quite large. The remaining 2 families of teid-formed lizards are the Gymnophthalmidae, often called spectacled lizards or microteids, and the Elapoglossidae, which we only recently discovered to be a separate family. Though they were previously lumped in with the microteids, I don't think that we have a good idea if they're more closely related to microteids or actual teids. So I'm leaving the relationship between these 3 families as a polytomy. And I'll start, somewhat arbitrarily, with the 250 or so described species of spectacled lizards. They are called spectacled lizards because they have a transparent eyelid, like what you would see in geckos or snakes, but unlike geckos or snakes, it's movable. They can move their transparent eyelids. So that seems like a good common name. I mean, you can take off spectacles, right? Yes, they're small, and yes, they're related to teids, perhaps the hagfish of teids, and they have the attributes of the laterata, like teids and everything else we're going to discuss in this clade, but they don't seem to have the fine bead-like scales on their backs. And they're often elongated with tiny limbs, more like skinks. Some even have highly reduced limbs, especially the hind limbs, which is unusual for lizards generally. But not really for the laterata, as we'll see later. These long bodies and tiny limbs actually betray that these are very reclusive little lizards that tend to stay concealed in the leaf litter and under objects, hunting very small prey. These little Central and South American lizards are very unique from teids in terms of scalation, body form, and basic behavior, but not so different from the 32 species in the family Elapoglossidae. Which probably explains why we only recently determined that they aren't the same thing. But from what I have observed, the best way to tell an Elopoglossid from a microteid is by looking at their chins. Microteids have scales on their chins that look essentially like a continuation of the scales on their necks. But Elopoglossids have like a foursquare court or a butterfly's wings made of 4 big scales that make up most of the bottom part of their heads. I can't promise that this is a hard and fast rule, but it's the best way that I have observed. They also seem to be more the shape of a traditional lizard, and less the tiny-legged stretch lizards that microteids tend to be. And just like that, we're out of the Teoformata and into the strange world of the Lacertibinia. which is only a half strange world. Because the Lacerta part, the Lacertidae, is such a run-of-the-mill group that they're often called the true lizards. You remember how we have true spiders and other spiders? Well, these are the true lizards. And given that their closest relatives are generally regarded to not be lizards at all, from a phylogenetic sense, if these are lizards and the amphisbaenians are not, then these are the only true lizards. All of the rest of the squamata would be, at best, false lizards. But we'll talk about that here in just a second, because I love Lacertas. I have multiple species of Lacertas here in Clint's Reptile Room. You should come in and see them. They're wonderful. And where all of the teid-form false lizards that we've been discussing so far have been from the Americas, the 360 species of Lacertas are from Africa, Asia, and Europe. Kind of reminiscent of what we saw in the carnivora. Lacertas are small to medium-sized lizards by most standards, with the longest being less than half a meter long. Though that would make that half-meter lizard, the Gran Canaria giant lizard from the Canary Islands, the largest lizard in the world. Assuming that the Lacertas are the only true lizards. So next time somebody tells you that the Komodo dragon is the largest lizard in the world, you can say, actually, and let me know how that goes. Despite being very speciose, they are very similar in basic body plan to one another. The main difference is just being in terms of color, pattern, size, and length of tail. They have the square belly scales and banded tail scalation typical of the Laterata. Their back scales are very small and similar in appearance to those of teids, with some of those tiny scales being tiny bony osteoderms, like crocodilians. They tend to have relatively long legs and shorter bodies compared to those of false lizards like skinks and microteids, though their tails are sometimes extremely long. Basically, they look like relatively generic lizards, especially generic lateratans. They have forked tongues, and most are insectivores. The scales on their heads are large, very similar to teids, or even to colubroid snakes. Though the lip scales are large, they aren't as distinct as those of teids in my experience. And they're found on the other side of the world, so that should help clear up any confusion. And despite many morphological similarities to the teids, remember, the Lacertids are not the closest relatives of the teids. And the closest relatives of the Lacertids are these, the amphisbaenians. And often called worm lizards by people who, in the same breath, tell you that they aren't lizards. Of course, they aren't worms either. So what the heck are they? Well, let me start with the fact that they are weird and cool. They look like worms, at least at first glance, at least in the sense that many of them are legless, unless of course they have giant crazy mole arms. Many are pink, though not all, and they appear segmented like annelid worms. Though if you notice their little skin-covered eyes, dry scaly skin, lack of external ears, or forked tongue, you might think that you found some sort of a snake. And there are many fossorial snakes that do look somewhat like worm lizards. Many of those snakes even have blunt tails like amphisbaenians. So how do you know that you have a worm lizard and not a snake? Well, you might notice that, like snakes, they have only one functional lung. But it is the right lung that is reduced, and not the left lung like in snakes. But I doubt that's how you'll tell. You might notice that their skulls are extremely different from those of snakes, with very robust, strong jaws. You'd notice if one bit you. They can bite a chunk right out of you. Very unsnake-like. If it has external legs, you will likely notice that they are the forelimbs, not the hind limbs like in snakes. But most are totally legless, which, like in snakes, seems to have evolved multiple times. So the way that you will tell is that you will look for the rings of rectangular scales, especially on the belly where snakes have scutes. Remember, these are part of the Laterata. There are literally dozens of different lineages of legless, false lizards, and these are the only ones in the Laterata. So it is pretty easy to distinguish them from the other legless false lizards. Though distinguishing between the 6 families of amphisbaenians, that can be more difficult. That's right, there are more families of amphisbaenians than there are the other families of Lateratans. But before we dig into them, I want to ask you a question. Are they lizards? At face value, I can totally see how you could conclude that they're not. They don't really look like lizards. And they are the hagfish of lizards, assuming that Lacertas are the only true lizards. So I guess the question is, Archaeans lizards? Because if they are, and Lacertas are lizards, then all of the Laterata would be lizards, including the amphisbaenians. What about monitors? Are they lizards? How about bearded dragons? Are they lizards? Because if either of those are lizards, and Lacertas are lizards, then so are the amphisbaenians and the snakes. You wouldn't even need to include the skinks, geckos, or Dibamids, or their closest relatives. But amphisbaenians and snakes, they'd still be lizards. There isn't a lizard clade that can be made that includes Lacertas, the true lizards, and any other group of animals alive today where amphisbaenians aren't part of the deal. So are they lizards, or are they the hagfish of lizards in a sea of false lizards? I'll let you decide. As for me and my house, we're calling Lacertas and iguanas lizards, so the snakes and amphisbaenians are coming along for the ride. In fact, I'm even going to consider skinks and geckos to be lizards. Which means that lizard is going to be nearly synonymous with squamata, but not quite. Because while I have never seen anybody try to exclude the Dibamids from the lizards, including Wikipedia, for the life of me, I can't see why not. They're still the hagfish of lizards in a world where Lacertas and even geckos are lizards. They're plenty unlizard-like. So if you want to kick out a squamate family from the lizards, I can't see any good argument for why it wouldn't be this one. So Amphisbaenia, Serpentes, you're in. Dibamids, you might be out. And geckos, you better watch yourselves. Good thing most of you don't blink because, your eyes are always closed. Okay, so worm lizards are going to be lizards. At least today, we're calling them lizards. And this species, Rhinura floridana of Georgia and Florida, is the only remaining species in the family Rhinuridae, which was once found across North America. It's a living fossil. And given that it lives underground, it's a fossorial living fossil. A fossorial living fossil from Florida. And this fossorial fossil, famously found in Florida, the hagfish of worm lizards, is often called the Florida worm lizard. It is pink and generally under a foot in total length. It has no visible eyes, and its legs are entirely absent. It really looks like a worm, at least until it sticks out its little forked tongue or opens its mouth. Then it looks like an exogorth. You know, the thing that ate and then almost re-ate the Millennium Falcon. Honestly, if you ever examine the stomach contents of one of these things, don't be shocked at all if you find a few minocs. The mouth is recessed a bit behind the snout, which is used for burrowing. It's kind of a shark-like arrangement. Anyway, a totally rad creature that you would be lucky to find. I know it'd make my day. It is pretty uncontroversial that the Florida worm lizard is the most distantly related family of worm lizards. But there is some question about the placement of this family, the 3 species of Mexican mole lizards of the family Bipedidae, the weirdest of the amphisbaenians. And they're weird because, while they still look like worms, they also have giant mole legs in the front, which they use for digging, so they lack the shovel nose of the Florida worm lizard. And this means that their mouth comes to the end of the head. They also have visible eyes, and they tend to be slightly smaller than Florida worm lizards. But if the fact that you're in Mexico combined with that pair of front legs doesn't give them away, I really don't think I can help you identify these things. Some phylogenies place them as the next most distantly related family to the remaining 4 after the Florida worm lizard. And some place them over here, sister to the families Blanidae and Cadiidae. Since the former placement reflects the most recent phylogenies I can find, we're gonna put them as the next most distantly related group after the Florida worm lizards. And given that both of the most distantly related groups are found in North America, it seems plausible that this is where the amphisbaenians first evolved. This is also reflected in the fossil record. But from here, the story gets pretty interesting. Because the last 4 families are divided into 2 clades of 2 families each, and most of them are found outside of North America. And given that we've already mentioned the families Blanidae and Cadiidae, let's start there. So again, these may be the closest relatives of the Mexican mole lizards, but probably not. The family Cadiidae contains the 2 species of Cuban worm lizards. They look a lot more like a Florida worm lizard than like a Mexican mole lizard. They have no digging legs, or any legs at all. But given that the Mexican mole lizards are more closely related to these guys than are the Florida worm lizards, that shows that legs have been lost at least twice already in this group. And given that these guys don't have legs, their noses are more shovel-like and extend beyond the mouth opening. more like the Florida worm lizards. They may be pinkish on the sides, but they seem to have more browns and speckles on top, distinguishing them from their distant Florida cousins. They also have small but visible eyes, and are found in Cuba, which is close to Florida, closer than you probably realize. But if all the cars around you were made in the 1950s and you're holding a worm lizard, it's probably a Cadiid. But if you're in Africa or Europe in the vicinity of the Mediterranean Sea and you're holding a worm lizard that fits this description, it's probably one of their closest relatives, the 7 species in the family Blanidae, the Mediterranean worm lizards. Though the heads of some blanids look more like Mexican mole lizards, despite the lack of limbs. Some species are very dark in color, but some are as pink as a mole lizard. You might swear that you had a mole lizard, except for how far you are from Mexico and how non-existent its forelimbs are. So that is the first family of amphisbaenians that we have discussed that lives farther than about 150 miles from mainland North America. Evidence of at least one major dispersal event from a group that really don't seem like they would be great at dispersing. So how did the blanids get so far from North America? Probably the same way that their closest relatives, the Cuban worm lizards, got to Cuba, rafting. If you're hanging out in the roots of a plant or something else that gets washed out to sea in a storm or as a riverbank erodes or something like that, you might just find yourself in Cuba. But if you miss Cuba, well, there's nothing to stop you until the westerly winds take you to Africa and Europe, where they come together right where the Atlantic Ocean meets the Mediterranean Sea. And that brings us to the final clade of amphisbaenians, and indeed of the Laterata. And this clade includes the families Trogonophidae and the family with perhaps the most interesting story of all, the family Amphisbaenidae. Big part of the reason that this clade is so interesting is because it isn't found in North America at all, though it is found in South America. And they got to South America in one of the most roundabout ways possible. So let's start with the Trogonopidae, because that will give us a start to this story. The 5 species of Trogonopids are found in a weird place, especially if you don't know a ton about geography or 16th century seafaring. They're often called desert ringed lizards. Ringed lizards make sense, all amphisbaenians are ringed, but they live in desert? Well, they live in Northern Africa, East Africa, and the Middle East, which seems odd until you realize that all of those places are straight east of North America, and that the westerly winds always blow east across the Atlantic Ocean from North America. So just like the Mediterranean worm lizards, the ancestors of the desert ringed lizards were likely blown east on an earthen raft. But the big difference may just be that the ancestors of the desert ringed lizards didn't hit land where Europe and Africa sometimes, but not always, touch, but instead made it through the Strait of Gibraltar at a time when it was open, like it is today, and thus made it into the Mediterranean Sea, continuing east across the Mediterranean until the sea ran out, and then radiated out by land from there. This is actually the only group of amphisbaenians that I have seen in person. And they're still plenty weird and limbless, but are honestly a bit less worm-like. Probably why they call them ringed lizards instead of worm lizards. They're a little shorter for their girth and tend to be light in color with dark speckles more than pink. Their tails are more pointed than those of many of the other amphisbaenians, though their faces are still good shovels and have that more shark-like morphology. And they have fairly apparent eyes. And if you find a skeleton, their teeth are fused right into their jawbones. That's a real giveaway. And that's all well and good, but how did the closest relatives of these swabbies, the amphisbaenids, get to South America? Well, the more than 180 species of amphisbaenids, which are often called worm lizards with no modifier since the majority of all extant worm lizards are in this family, they are also found where the desert ringed lizards are found, but also farther south in Africa, up into Asia, and even in Europe. It is entirely plausible that the same colonization event brought the ancestors of both families over, because the two families didn't diverge until after they had arrived. But the amphisbaenids have been the more successful group of descendants of these initial accidental pioneers, giving them the greater range and diversity. And it is really important that they made it further south, because up north, all voyages go from west to east. But south of 30 degrees north latitude, it's a very different story. Instead of hitting the west to east westerly winds, you hit the east to west trade winds. These westward winds blow across the Atlantic from the central part of Africa to South America and the Caribbean. So in addition to Africa, Asia, and Europe, can you guess where you find Amphisbaenids? You got it. South America and the Caribbean. This is a super diverse family. They're all legless and look like amphisbaenians. But the best way to identify one is first to know where you are. If you're in North America, probably isn't one. If you're anywhere else, it probably is. Especially if you're in South America or if it doesn't fit the description of the other groups that we've described. But these are probably the weirdest, can we say, lizards on the planet? So those are the lizards, the most unquestioned of lizards, as well as their closest relatives. Of course, if skinks or any of the other groups that we've discussed today are lizards, then they were all lizards, as are the squamates that are yet to come. Because all of the families that we're about to discuss, well, they're all more closely related to the lacertids and all of the other laterotans than they are to any of the groups that we discussed previously. If you think that the lacertids are lizards and anything else that we will discuss from this point on, then everything from this point forward will be a lizard as well, including this group, the roughly 4,000 species of snakes in the suborder Serpentes. And these nearly 4,000 species fall into more than 20 families, most of which you've never heard of before. And these are the true snakes. We're not even talking about the 24 other lizard lineages that have no legs that people often ask why they're not snakes. And the reason that they're not snakes is because they're not as closely related to snakes as they are to the other lizard groups. There are a suite of snake features that can be used to distinguish between snakes and other lizards. Even other lizards with reduced or absent limbs, like this European legless lizard. These features include the presence of belly scutes, an unfused mandible and a highly kinetic skull, a forked tongue, a fused, immobile, transparent eyelid called a brill or spectacle, a lack of external ear openings, a long body and a comparatively short tail, and a lack of a sternum connecting the ribs on the ventral side of the animal. Other groups may have some of these features, but none other than the snakes possess them all, or even the majority of these features all on the same individual. But the combination of these features has resulted in the single most successful, at least in terms of the number of species, group of lizards on the planet. And they're found almost everywhere, except for Antarctica and a few islands. I mean, even out in the ocean. So how many snake families are there? A lot. Certainly more than 20. And given the number of species, there is still a lot for us to understand. So take the exact number and the relationships with a grain of salt. But let's dig in, because I suspect most of us can name fewer than 10 families of snakes. And that means we have a lot to learn. The snakes, suborder Serpentes, are, as we mentioned, nested right in the middle of the lizards, which are in the order Squamata. The Serpentes are themselves divided into two large clades, the Scoliocophidia and the Elithinophidia. The Scoliocophidia contains 5 families of weird fossorial snakes, and the Elithinophidia contains all the rest of the snakes, including the ones that you can probably name. So let's start with the Scolicophidia, since it is a comparatively small and very weird group. And these are generally small and weird snakes, so it seems appropriate. In general, members of this clade, which may be paraphyletic, are known as blind or thread snakes. They can get up to about 3.5 feet, or about 1 meter, but many are much smaller than that. The main unifying feature of these blind snakes is that they are quite visually impaired. Not only do they have reduced eyes, but their spectacle is opaque. This probably doesn't matter much since they live underground, and they probably just use their eyes to detect if they are still safely in the dark, or if they have accidentally emerged into the horror that is broad daylight where death is around every corner. The 5 families in this clade are the Anomalipitidae, the Leptotyphlopidae, the Gerhopilidae, the Xenotyphlopidae, and the Typhlopidae. The Anomalipedidae, the most distantly related of the 5, is found in Central and South America. They are mostly under a foot in length, and many species have a single tooth in their lower jaw. Let's call him Brian. The next most distantly related family are the Leptotyphlopidae, which are found in the Americas, North and South, Africa, and Asia. This is another family that stays small. The smallest snake in the world is actually in this family. They have non-mobile, toothless upper jaws and crania, much less mobile than most snakes. The next most distantly related family would be the Gerhopilidae. These are found in southern Asia and the South Pacific. They can be identified by the gland-like structures that they have on their head scales. The two most closely related families in this clade are the Xenotyphlopidae and the Typhlopidae. The Xenotyphlopidae are made up of just 2 families of snakes from Madagascar known as Malagasy blind snakes. They can be identified by a huge, almost circular, shield-like scale at the front of their face called a rostral shield. Also, they have no eyes and are pink. Let's just say that if you're in Madagascar and you find a dry worm with scales and a shield for a face, well, you'll know what you have. The Typhlopidae are found in the tropical regions of every continent except for the one without any tropical parts, as well as many islands all over the world. These guys have teeth in their upper jaws, but lack basically all of the head flexibility of most snakes, so they can only feed on very small prey. And that takes us to the Althenophidia, which are, if not less weird, at least more familiar. And that makes sense because there are, at least like 20 families in this clade distributed around the world, and most of them live above ground like we do. Within this clade, the most distantly related from all the rest appear to be the snakes of the clade Amerophidia. The Amerophidia contains 2 families which you might not think are closely related, but no matter how we build the phylogeny, it keeps coming back that they are one another's closest relatives. First is the single species family Annelidae, the American pipe snake. This is a long, skinny, small-headed South American snake with red and black bands, leading them to be called false coral snakes. But unlike most long, skinny, small-headed snakes, they have vestigial hind limbs called spurs. Their head and eyes are also fairly similar to the blind and thread snakes. And because their jaws are not very flexible, they tend to eat things that are easy to swallow, like other snakes, caecilians, and amphisbaenids. Unlike the scoliocophidian snakes that all lay eggs, these guys are ovoviviparous, meaning that they retain the eggs internally until they hatch. Their closest relatives, members of the family Tropidophiidae, on the other hand, look at a glance a heck of a lot more like boas than they do like American pipe snakes. These are found in the Americas from Mexico down into South America and all over the Caribbean islands. Like their closest relatives, and the boas that they resemble, they have vestigial hind limbs and give birth to live young. They also have the ability to change color from light to dark, which is pretty neat. When threatened, they coil into a tight ball like a ball python, or voluntarily bleed from their eyes, mouth, and nose like someone possessed by a demon. The next most closely related clade are the Europeltoidea. This clade contains 3 families: the family Europeltidae, the shield tails, and the families Anomochylidae and Cylindrophiidae, the dwarf and Asian pipe snakes. The family Europeltidae, found in India and Sri Lanka, are another fossorial group of snakes with reduced eyes and relatively inflexible heads. Unlike the blind and thread snakes, they do not have a brill at all, but their eyes are covered with polygonal shields. Unlike the Amerophidia, they don't have any vestigial limbs, but they do have a 2-pointed shield at the end of their tails, hence the name shield tails. Being fossorial and with relatively inflexible heads, they seem to eat primarily earthworms and other things that are small and easy to swallow. Similar to Amerophidia, they are ovoviviparous, retaining the eggs until hatching. The family Anomochylidae, the dwarf pipe snakes, contains 3 species from West Malaysia and Sumatra. Not much is known about them. They're small, up to about 20 inches. They probably are fossorial, given their head and eye structures. They probably lay eggs. They do have some reduced hind limbs. Really, more is known about their closest relatives, the Asian pipe snakes, from the family Cylindrophiidae, named for their cylindrical bodies, hence the name pipe snakes. Asian pipe snakes are found all over southern Asia and the nearby islands. They tend to be dark with bright blotches and have bright banded ventral patterns that are revealed as part of their defensive displays. They do possess spurs. They are semi-fossorial, and as a result, they have more developed eyes and more skull flexibility than most of the snakes we've discussed so far. Some species get a bit larger, up to about 34 inches, but many are pretty small. Though their more flexible skulls allow them to eat larger prey than most of the families we've talked about so far, they eat using this strange rotational motion that I don't yet totally understand, as opposed to the pterygoid walk we explained in this video. As a result, they still tend to feed on tube-shaped prey. Pipe snakes eat other pipes. Even though we are quite a ways into this more familiar clade of snakes, we really still haven't gotten to anything all that familiar. And that is because the 3 remaining clades contain basically all of the snakes you have probably seen before. You may have also noticed that the overwhelming majority of the snakes we have discussed so far have legs. Only 2 of the remaining 3 clades have legs. Usually I say that snakes don't have legs unless they do. I should probably start to say about snakes the same thing that I usually say about the rest of the lizards. They have legs unless they don't. Because almost all of the snake clades have legs. So, let's talk about the 2-legged clades first. These would be the Pythanoidea and the Booidea. While both of these lineages have legs, that doesn't mean that they are one another's closest relatives. The reality is that we are still struggling to determine which 2 of these 3 remaining clades are most closely related. The Booidea contains the family Boidae, the true boas, as well as the families Calibariidae, Candoiidae, Carinidae, Euricidae, and Sanzinidae. These are considered by some to be their own families, but they're often simply included as subfamilies in the Boidae. This is one of those places where there's a lot of room for study, if you're looking for a PhD project somewhere. But the boids, despite being one of the best known families of snakes, only comprise a few dozen species. We could probably cover them all in one video, if you're into that kind of thing. And I have a very exciting announcement, assuming that you're into that kind of thing, because later this month, we're going to release that documentary. That's right, you're getting 2 epic documentaries this month alone. Because it truly will be a documentary on all of the boas, every species. So if you don't subscribe already, now might be the time. However, if you're this deep into this video, I bet there's a good chance that you've subscribed already. Where else are you going to get content like this? They're found mostly in the Americas and the Caribbean, though there are a few species in Africa, Madagascar, Europe, Asia, and the Pacific Islands. So though I tend to think of them as an American group, they do have some representation on all of the continents with snakes, except for Australia. Probably a cool story there we would get into if we did a full video on just the boas. Again, if you're into that kind of thing. This family includes many well-known snakes like anacondas, boa constrictors, rainbow boas, sand boas, Dumeril's boas, rosy boas, rubber boas, and tree boas. Not to mention the largest snake ever discovered, the titanoboa. And though the titanoboa is now extinct, the heaviest of all living snakes, still a boid, the green anaconda. So what they lack in numbers, they make up for, in many cases, by being large and spectacular. Like almost all of the snake families that we have discussed so far, they do have vestigial hind limbs. The main group with which they are likely to be confused would be the Pythanoidea. Though there are some dental and skeletal elements that you could examine, the easiest ways to identify them would be by their babies and their heat pits if they have them. Boas, unlike pythons, generally give live birth, though there are a few species that have re-evolved oviparity, just to wreck our day. Additionally, where present, the heat pits, called labial heat pits as they're positioned on the lips, are located between the scales, whereas they're located on the labial scales of pythons. The Pythonoidea, like the Boidae, contains only a few dozen species that could be covered in their entirety in a single video, if you're into that kind of thing. The majority fall into the family Pythonidae, but there are a few that fall into the families Loxosemidae and Xenopeltidae. The true pythons, the family Pythonidae, unlike the boas, are found in Australia. They're also found in Africa and Asia. Only recently have they established themselves in the Americas, and that is mostly the Burmese pythons in southern Florida. There is a species commonly referred to as the Mexican python. Mexico being, in the Americas, but it is not a pythonid. The family Pythonidae contains the longest snake in the world, the reticulated python, as well as many other well-known species such as ball pythons, tree pythons, womas and black-headed pythons, blood pythons, carpet pythons, just to name a few. And again, I'd be happy to cover them all in the future, if you're into that kind of thing. Getting back to the American python, they do exist, they just aren't in the family Pythonidae. They are, however, very closely related. They are the only species in the family Loxosemidae. So there is an American member of the Pythonoidea, it just isn't a pythonid. The other family in the Pythonoidea are the sunbeam snakes of the family Xenopeltidae. These are from Southeast Asia. In a lot of ways, these guys resemble the last group of snakes we have to cover, the Caenophidia. This in that they lack hind limb vestiges. Also, like many members of the Caenophidia, they have large rounded head scales. They're also very, very iridescent. This makes them a popular target for pet snakes, but they generally do terribly, like dragon snake level terribly in captivity. And that gets us to the biggest clade of snakes, the legless snakes in the clade Caenophidia. Despite the fact that the overwhelming majority of all the clades we have discussed so far have possessed legs, this clade comprises about 80% of all known snakes. That's probably why we tend to think of snakes as not having any legs. This clade includes two main lineages, the Acrocordoidea and the much larger Colubroides. The Acrocordoidea contains only one extant family, the family Acrocordidae. These are from southern Asia, Indonesia, Australia, and other islands in between. But what the family Acrocordidae may lack in diversity, it more than makes up for in extra skin and weirdness. These are the wart, file, and elephant trunk snakes, and they are a weird, baggy aquatic group. They basically look like an anaconda that shed into its 5-year-old skin when it was only 2. So much skin. It's just a long aquatic lychee, except where lychees are soft, these guys are very rough for holding the fish on which they prey. They also have no belly scoots. There might be a reason they were on our list of 5 of the weirdest pet reptiles you could get. The Colubroides, on the other hand, are probably what you think of when you think about snakes. The Colubroides includes the family Colubridae, but I don't want you to confuse the two. This is a colubroid snake. And so is this. And so is this. And so is this. As it turns out, the Colubroides comprise about 85% of all of the snakes. So it didn't seem right to glaze over them, if for no other reason than that it includes some of the most dangerous and awesome of all snakes. There are many subtle anatomical features that differentiate the Colubroides from the host of other groups that we have discussed so far. For example, the Colubroides lack the right carotid artery that delivers blood to the head. And males have little fleshy spines covering their hemipenes. But unless you are examining dissected specimens or make a habit of regularly inspecting the hemipenes of all of the snakes that you encounter, most of these will be difficult to observe. But, as we noticed in the last video, almost all of the snake lineages have legs. Snakes have legs unless they don't. Well, this lineage, the Colubrids, lack legs. They aren't the only lineage without legs, but if you find a snake, any type of snake, the odds are good that it is in the Colubrids. And if it lacks all leg vestiges, then you almost certainly have a member of this group. Though it wouldn't hurt at all to, watch this video to familiarize yourself with the other possibilities. And because over 85% of all snake species are in this lineage, it makes sense that people are generally surprised to discover that there are snakes with legs at all. The most distantly related family to the rest of the Colubrids. In fact, so distant that there is some dispute about whether it should be included or not, is the family Xenodermidae. These are a family of snakes found in Asia, all measuring less than 1 meter in total length, with most under 2 feet. They are secretive, nocturnal snakes found in moist forest habitats. Though it is a poorly known family in general, you may be familiar with the dragon snake, Xenodermis javanicus, which belongs to this family. And it has to be one of the most radical looking of all snakes, though it certainly does have some competition in the rest of the Colubrids. The next most distantly related family would be the family Pariidae. These are also from Southeast Asia, with one subfamily in India. Most are active predators, with many feeding primarily on snails. They even have asymmetrical jaws, which assist in feeding on snails, which themselves are asymmetrical. Worldwide, about 95% of snails whirl in the same direction. They are right-handed, or dextral. Only about 5% are left-handed, sinister. But in the range of these snakes, about 12% of the snails are left-handed, likely due to the fact that left-handed snails are harder for these snakes to eat. The next most distantly related family within the Colubrids is possibly my favorite family of snakes, period, the Viperidae. And why are the vipers my favorites? Probably because they are so incredibly rad. For one thing, these are the first group that we have discussed with deadly venom that they can inject into prey to immobilize, kill, and digest it. And that venom is delivered through a pair of movable fangs that fold when not in use, allowing them to be much longer than those of other snakes, even other snakes that have fangs. Look at those things. It also means that they can swing into a more forward position so that the snake does not need to get a good bite to envenomate. They almost spear stuff with their fangs. They store their venom in a pair of venom glands behind the eye that gives their head a very recognizable arrowhead shape. That's just glorious. And one group, the pit vipers, have well-developed heat pits. These function similarly to the pits of the boas and pythons, except there are only 2, located on the loreal scales between the nostril and the eye, and they're called loreal pits. They are used to detect infrared light, which is emitted generally by things that are warm. Thus, they effectively have heat vision due to these loreal pits. Vipers are found on every continent except Australia and Antarctica, though Australia has a snake that is insanely viper-like, but isn't, and we'll go into that very soon. Most of the vipers are ovoviviparous, retaining the eggs and giving live birth, though some do lay eggs. This family includes some of my absolute favorite snakes, such as the bushmasters that we found in the Peruvian Amazon, but also rattlesnakes, gaboon vipers, eyelash vipers, the amazing spider-tailed horned viper, copperheads, cottonmouths, and rhinoceros vipers, just to name a few. I'd love to make a whole video just about this family. If you're into that kind of thing. The next most distantly related family is the family Homolopsidae, the Indo-Australian water snakes. This is a very unusual family that includes the tentacled snakes that we discussed on our list of the weirdest pet reptiles that you could get. All members of this family are mildly venomous. And this family includes the only snakes known to dismember their prey before swallowing it, as some tear apart crabs with their coils in order to make them more manageable to consume. The remaining snake families are all more closely related to one another than they are to any snake we have discussed to this point. And this remaining clade itself contains 2 big clades, the Colubridia and the Elapoidea. Do not confuse these clades with the families Colubridae or Elapidae, though those families are contained within these 2 clades. The Colubridia is sometimes argued to contain around 5 families. though most of the time those 5 are all considered to be part of the single family Colubridae. In the past, this family was basically a garbage bin for all legless oddball snakes. But a lot of recent work has removed the unrelated snakes and made it into a proper clade, though it is still the largest of all families, containing well over 200 genera, found on every continent except for Antarctica. Most are non-venomous, though there are a few with medically significant venom like the boomslang and the keelback snakes, which are also poisonous, no big deal. This group also includes snakes like garter snakes, rat snakes, hognose snakes, king snakes, false water cobras, mangrove snakes, vine snakes, indigo snakes, bull snakes, and on and on. The reality is that if you're thinking of a snake that you could name before you saw these videos that doesn't have front fangs or back legs, it's probably in this family. We could easily make a whole video or even multiple videos just about this clade. You know, if you're into that kind of thing. Within the Elapoidea, the most distantly related family to the rest is the family Pseudospididae. This is a very small family of snakes from Africa and Asia. One of which, the mole snake from Africa, grows to 2 meters in length, gives live birth to huge litters, frequently larger than 50, and notoriously bites like crazy. The remaining 2 families are much larger. The family Lamprophiidae is one I only discovered recently, as it contains the African house snakes. In addition to the African house snakes, the family Lamprophiidae also contains one of the coolest and most terrifying of all snakes, the stiletto snake. The stiletto snake really doesn't look like too big of a deal. They actually look basically exactly the same as this black African house snake. Their venom causes necrosis, which you don't want as it may cost you a finger, but death is very unlikely from a stiletto snake bite. So what makes them so terrifying? Well, it might be the fact that they have ginormous, highly mobile things that they can protrude from the mouth and reach around and get you even while the snake has its mouth closed. They are so amazing. And there's really no safe way to handle them because even if you have them behind the head, they'll still get you. Most of the Lamprophiid snakes, though, are not venomous. They are found mostly in Africa, but also in Asia and Europe. And the last group of snakes that we have to discuss may not be able to envenomate you with its mouth closed. It might not contain the largest of all snakes, have the fastest strike, or have the longest fangs, but it is a group that kills the most people. It contains the most venomous of all snakes, the inland taipan, the longest of all venomous snakes, the king cobra, and the fastest snake in the world, the black mamba. And while most have short fixed fangs that make envenomation more difficult than it is for vipers, they are much more athletic than their mobile fanged cousins. I would rather have to catch 100 rattlesnakes than deal with just one mamba. And I must say that dealing with the longest viper in the world, many hours away from the nearest medical facility, was nowhere near as terrifying as handling the longest member of this family, only minutes away from a great hospital. So the final group that we have to cover is the family Elapidae. And what a way to finish. I was fortunate enough to be able to catch and interact with multiple species of coral snakes during my recent trip to the Amazon. Elapids are found mostly in the southern hemisphere, but are on every continent except Antarctica and Europe. They're even out in the ocean, like the one we found on the island of Niue. They are very prevalent in Australia. And earlier I mentioned that there are no vipers in Australia, but then I remembered this snake, the death adder. This is a heavy-bodied, slow-moving ambush predator with long, movable fangs and elliptical pupils. They are ovoviviparous, giving live birth, unlike most elapids. This is clearly a viper, but Australia has no vipers. The death adder, for all of its similarity to the vipers, is an elapid. This is an example of convergent evolution, and what an example it is. Death adders are not vipers, and if that isn't bad enough, king cobras are not true cobras, and neither are the tree cobras. So I think we might need a whole video just about the elapids, and maybe just the cobras, since there are over 30 different species. You know, if you're into that kind of thing. And that concludes our tour of all of the snake families. But not our tour of the Lepidosaurs, because we haven't yet covered the closest relatives of the snakes. Yes, the snakes are more closely related to the true lizards and the rest of the Laterata than they are to any of the groups that we discussed before that. But the remaining lizards, if we're calling anything out of the Laterata lizards, are all more closely related to snakes than they are to the Laterata or anything we discussed before. And those two clades would be the Anguimorpha and the Iguania. And again, if anything in either of these groups are lizards, and the true lizards are lizards, then so are the snakes and the amphisbaenians. This is the largest lizard that isn't a snake on the planet today. And they are part of the family Varanidae. Excluding the snakes, which, as I just hinted, are just as much lizards as are the members of the Anguimorpha, the Varanids are only in competition with the skinks for being my favorite group of lizards. And I definitely like the Anguimorpha more than I like the Skinkiformata, which probably has something to do with why the Anguimorpha gets its own video. This is such an awesome group of lizards. The Varanids are often referred to as monitor lizards, though in Australia they're often called goannas. Goanna is actually a mispronunciation of iguana, which Varanids are not, though they are more closely related to iguanas than they are to tegus. But they're not iguanas, and everything in this entire video is more closely related to them than they are to iguanas. They're just big lizards. And while iguanas tend to be herbivores, most Varanids are carnivores. Except for 3 species in the Philippines that eat mostly fruit. Unlike iguanas and tegus, monitor lizards are found in Africa, Asia, and Oceania, which is Australia and all of the islands in its general vicinity. This includes Komodo, home to the Komodo dragon, the aforementioned largest lizard that isn't a snake, that is currently alive. I stress currently because there's good evidence that mosasaurs, that we discussed last Dinosaur December, are not only not dinosaurs, but lizards. And not only lizards, but members of the Anguimorpha. And some of them got over 50 feet long. Komodo dragons are less than a fifth that long. A mosasaur could swallow a Komodo dragon like a Komodo dragon could swallow an Ackie monitor. And that isn't even the largest monitor lizard of all time. The largest known monitor was the Megalania of Australia. They got to 15 feet, maybe over 20 feet long. And it was still there 50,000 years ago. The first people in Australia may have seen them, perhaps even contributed to their extinction. Australia is also home to the smallest of all known monitors, the Dampier Peninsula monitor, that is only 23 centimeters long. So they're not all huge. So Varanids might be the most varied of all lizard families in terms of size, but not really in terms of body plan. Though some are more arboreal, others semi-aquatic, some eat fruit, others eat water buffalo, their basic body plan is astoundingly similar. They can be recognized by their forked tongues and the use of their necks in breathing. This ability to push air into their lungs allows monitors to breathe while on the move, an ability that most lizards lack. And that is just the beginning of the amazing ways that monitors obtain and distribute oxygen. They have a heart with a septum that keeps their pulmonary and systemic loops separate, almost like a 4-chambered heart found in crocodilians, birds, and mammals. But that long neck, positive pressure breathing with a generally rather sharp face and forked tongue will generally allow you to identify a monitor lizard. You definitely will not confuse them with their closest living relatives, the earless monitors, which are not monitors. They are the only living members of the family Lanthanodidae, which are one of the main reasons that I want to go to Borneo. But that is the only place on Earth where they're found. And despite being the closest living relatives of the Varanids and being called earless monitors, you are very unlikely to mistake them for monitors. In fact, morphologically, they more closely resemble the beaded lizards and Gila monsters of the family Helodermatidae. So much so that before molecular phylogenetics, they were sometimes classified as part of the Helodermatidae, which is also part of the Anguimorpha, so stay tuned. That said, you are unlikely to mistake them for beaded lizards, despite the similarity in head shape and somewhat beaded appearance. For one thing, they're in Borneo, not North or Central America. They are brown in color with longer necks, more like the neck of a monitor. They're proportionally just longer in general, almost like you took a tiny brown beaded lizard, grabbed it by the head and tail, and stretched it out like Stretch Armstrong. Add to that the beads on their back form uniform rows. They really remind me of dragon snakes. And, like snakes, their ears are covered. They have no external ear openings, hence the common name. They also have beautiful blue eyes, unlike the dark eyes of beaded lizards. And you're likely to find them in or around water. And they're generally smaller than beaded lizards, maxing out around 16 inches, though larger individuals have been observed. Honestly, if you're going to confuse an earless monitor with anything, which you probably won't, I guess it would be with their next closest relatives, the crocodile lizards of the family Shinosauridae. Crocodile lizards, like earless monitors, are brown, semi-aquatic with bumps all down their backs. They're also just about the exact same size. And while they're not from Borneo, China and Vietnam are at least closer to Borneo than Guatemala is. But that isn't the only reason that you're not going to confuse the two. Ignoring for a second that their heads are completely different in shape, crocodile lizards usually have alternating light and dark bands. Their back bumps are not arranged into lines as with earless monitors. They look more like crocodiles. Who would have guessed? And their bellies tend to be reddish. And now we can talk about their short, tall heads and dark eyes that are nothing like the long, flat heads and blue eyes of earless monitors. Though it is a bit hard to use ears to distinguish them. It's hard to see the ears on crocodile lizards. And they're both mildly venomous, as are many monitors, arguably all of them. But they aren't the most famously venomous of all the members of the Anguiomorpha, because the most famously venomous of all lizards are also in this group, though they're in the other major clade of the Anguiomorpha. Anguiomorpha means snake or dragon form, and the three families we've discussed so far comprise the Paleoanguiomorpha, or the old snake or dragon form lizards. The remaining 5 families all fall into the Neoanguiomorpha, or the new snake or dragon form lizards. All of these 5 remaining families are more related to one another than they are to any of the old snake form lizards. And the old snake form lizards are all more closely related to one another than they are to any of the new snake form lizards. In fact, all of the new snake form lizards are equally related to the Komodo dragon, as well as the other monitors, the earless monitors, and the crocodile lizards. So they are, as a group, the next most closely related lizards to Komodo dragons. And let's start with the family for which the entire clade Anguiomorpha is named, the Anguiidae, the alligator or glass lizards. I freaking love this group. And I know I say that a lot, but look at these guys. There is a lot of convergence with the skinks, another group that you know I adore, especially the reduced or absent legs. And one of the 2 subfamilies, the Anguinae, are legless, so they could be mistaken for snakes, hence the name. My Sceltopusics are proud members of this subfamily, and people mistake them for snakes all the time. Even when I tell them that they're not snakes, they generally want me to explain why not, and I'm very happy to do so. They aren't. They have almost none of the defining features of snakes, but they do have all of the defining features of the Anguidae, including osteoderms and a lateral fold, among other less conspicuous features. The bony osteoderms under the skin give them an armored feeling, as it's armor. These feel nothing like snakes or skinks. And that lateral fold allows the body to expand when they eat or breathe, which is difficult if you are armored. These guys are found all over the northern hemisphere, and they probably need more representation here in Clint's Reptile Room. However, if you find a similar lizard in California or Baja California, then you might need to look a bit closer, because it could be one of their closest relatives, the family Anielidae, known as the American legless lizards. I don't love this name though, because there are other American legless lizards. These seem to be totally restricted to places with California in their names. So I would call these California legless lizards. Though there are other legless lizards in California, such as, well, snakes. And like snakes, their ears seem to be covered. But unlike snakes, they blink. They also lack most of the other snake features. To differentiate them from glass lizards, note the lack of a lateral fold, as well as the osteoderms. It is my understanding that they are very soft to the touch, though I've never touched one myself. But other things that you can look for to distinguish them from glass lizards are their blunt tails, and while glass lizards have somewhat intense faces, these guys have some serious derp. At least that's what they call it in the literature. But isn't that a derpy face? I love it! I want to see one. Brian, can you help me find these? And may I suggest that maybe instead of just calling them California legless lizards, we call them California derp-faced lizards? Because, I mean, look at that face. Now I have to say that this next family just put the Anguiomorpha over the top in my book. These were long thought to be part of the Anguidae, but molecular analysis revealed that they are not as closely related to the anguids as they are to the Annelids. So they clearly were not. They're part of their own group, the family Diploglossidae, more commonly known as gallywasps. I honestly have only known about these guys for a few years, possibly because they were just swallowed up among the anguids. But since the very first time I saw a picture of one, I have been in love with gallywasps. And they're almost all found in Hispaniola, aka Haiti in the Dominican Republic, though there are some species on other Caribbean islands and Central and South America. And they are gorgeous. Most look like skinks, and one is legless, like most snakes, but it isn't the same one that has no external ear opening, like a snake, though there is one that has no external ear opening, like snakes. And many of them are very colorful. I don't think that they have lateral folds like alligator lizards. They really do look like skinks. And some of them get pretty big, like almost as big as blue tongues. But again, they're not skinks. They're more closely related to Komodo dragons than they are to skinks. In fact, of all lizards, including snakes and amphisbaenids, only the Dibamid lizards and the geckos are less closely related to gallywasps than are skinks. And those guys are basically the hagfish of lizards. But if you had doubts about the Anguiomorpha being the coolest group of non-snake lizards because it doesn't include skinks, well, it has the next best thing, and Komodo dragons. And two more families that are absolutely incredible. But for now, let's get back to those last two families in what may very well be the coolest clade of non-snake lizards on the entire planet. The three families that we have discussed so far in the Neoanguimorpha are all more closely related to one another than they are to the two remaining families. But their next closest relatives are the family Xenosauridae, the knob-scaled lizards of Mexico. Knob-scaled lizards can easily be identified by that crazy look they generally seem to have in their eyes, but also by their round, knob-like scales. Their heads remind me a bit of Abronia alligator lizards or perhaps of leopard lizards, but those big knobby scales and that wild look in their often orange eyes definitely sets them apart. Though while we're on the subject of knobby scales, let's talk about the last family in the Anguimorpha. The most distantly related member of the Neoanguimorpha, but the most notoriously venomous lizard in the entire world. The family Helodermatidae, the beaded lizards. This family includes what is quite possibly my favorite non-snake lizard native to the United States, the Gila monster, which is kind of the runt of beaded lizards, growing no larger than about 22 inches, which is about the low end of the size of the other beaded lizards, some of which get up to around a meter long, perhaps even longer, which is big. But other than Komodo dragon, Gila monster has to be the next most common guess for what Gus Gus is. People are often shocked when I tell them that he could swallow a Gila monster whole. So how do you recognize an actual beaded lizard? Well, if you're in Borneo, it isn't one, especially if it's in the water. But if you are in the Americas, from Guatemala to the United States, and you see a head this shape, there is a very good chance that you have found a beaded lizard. That head is broad, muscular, with large venom glands in the bottom jaw and huge osteoderms all over it. Look at this skull. Look at those teeth. I fear those teeth more than the venom. And honestly, I see little evidence that the venom has ever killed anyone. Nobody has died from a Gila monster bite since 1930, and those that died before that seem to have died from infection, because they will chew on you with those teeth. The venom just adds searing pain to grievous mechanical injury. Until this year. As you may have heard, someone did manage to die from a Gila monster bite this year. But I'm no more concerned about it than I ever was. The specific captive Gila involved was tested and was producing a far more potent venom than is typical for a Gila. Plus, the person bitten happened to be allergic to the venom, and it still took 4 days for the venom to kill him. Interacting with Gilas isn't a perfectly safe activity, but Gilas have a lower body count than rocking chairs, and that gives you something to think about. That said, beaded lizards of all types are reclusive and prefer to avoid confrontation with humans. Just don't grab one and you should be fine. The fact that it is black, especially with any yellow or orange, should give it away as a beaded lizard. And just count your blessings that you saw one. Take a picture and don't grab it. And that concludes our tour of the Anguimorpha, which brings us to our final clade in the Lepidosauria. This is a thorny devil, one of the craziest looking animals in the world. And this is a horned lizard. Both of these are spiky little ant-eating lizards, and yet the thorny devil is more closely related to this than it is to a horned lizard. Same thing goes for this. It's more closely related to a chameleon than it is to this. This isn't an anole. Yep, it's closer to chameleons too. This isn't an anole either, but it does fly, or at least fall with style. And this isn't a Dilophosaurus, nor did Dilophosaurus have a frill like that. In other words, this is a lizard that is so cool that movie makers thought that they could improve one of the coolest dinosaurs that ever existed by making them a little bit more like it. And this is just the tip of the iceberg, because other than Dilophosaurus, all of these animals fall into the hyper-diverse clade Iguania. And yes, it also includes iguanas, as well as things like this, and this, and of course, these. The clade Iguania is composed of two separate clades, the Acrodonta and the Pleurodonta, which can most easily be differentiated by a close examination of their teeth, especially in a skull, where you can see clearly how the teeth attach themselves to the skull. In Lepidosaurs, there are two main ways that teeth attach to the skull. The simplest, and probably the weakest, is that the teeth are not anchored into the skull at all, but rather fused to the surface of the skull like the ossicones of a giraffe. These are called acrodont teeth. We see acrodont dentition in tuataras, like this one, though these aren't lizards, as well as some amphisbaenians and some snakes, which totally are lizards. At least if anything that we're discussing today are lizards. Then snakes and amphisbaenians, well, they are too. And acrodont dentition is probably, unsurprisingly, what is found in the Acrodonta. But there is another way. Most other lizards, like this Gila monster, have their teeth essentially in half sockets. As in, the teeth are in little bone channels. The outer surface of the tooth root is fused to bone, but the tongue side portion of the root is only secured by ligaments and is totally visible when looking at the bones without the tissue. So it's like a half socket. And this half socket dentition is called pleurodont. And if you had to guess which form of dentition the Pleurodonta possess, well, let's just say I will be unimpressed if you can't guess correctly. Altogether, the Iguania are the closest living relatives to the Anguimorpha, such as monitor lizards, Gila monsters, and their relatives that we discussed in this video. And after that, their closest living relatives are snakes. So they are more closely related to snakes than they are to lizards like tegus, skinks, or geckos, which is why you can't make a clade that includes iguanians and any of those that doesn't include the snakes. That's why snakes are lizards. And we have a video about all of them as well. But right now, I really want to talk about the Pleurodonta, because I have a big question about this group. This entire clade is found almost exclusively in the Americas. But then there is this iguana, which is found only in Fiji, which I think I understand. There is a straight path from the Americas to Fiji.
See here? Yeah. This is us. And all the way around here, Fiji.
The wind even blows from the east at that latitude. The ocean currents go that way. They probably got to Fiji in about the same way that the amphisbaenids got to South America from Africa, by rafting. It's a pretty straight shot from South America to Fiji. But that isn't my big question, because there is a whole family of pleurodontan lizards endemic to Madagascar. That means that they would not only need to raft from South America to Fiji, a voyage that is already nearly prohibitively long.
You can't get any further away before you start coming back.
But they would need to start coming back. They would need to miss Fiji, which isn't hard to do, but also New Caledonia, Australia, and one of the densest large conglomerations of islands anywhere on the planet. And then extend their journey that has already gone all the way across the Pacific Ocean, all the way to the other side of the world, and they would have to continue all the way across the Indian Ocean as well. The distance from Fiji to Madagascar is actually greater than the distance from the Americas to Fiji. So it would more than double the journey, all the while with minimal food and next to no access to fresh water. This journey would take the better part of a year. So if this is what happened, how did this happen? And if this isn't what happened, how did they get to Madagascar? And given that the pleurodontan lizards are some of the most amazing and common lizards on the side of the earth where I most frequently reside, it seems like a good place to start. But don't worry, I won't forget to talk about chameleons. I can forget a lot of things, but chameleons aren't one of those things. But this lizard is one that I have been seeing a lot in my recent trips to Florida. These are members of the family Leocephalidae, the curly-tailed lizards, though their scientific name means smooth-headed. And they do have pretty smooth heads, but man, if you spend any time at all watching these lizards and that was your takeaway, you were really focused on their heads the whole time. Because they run around with their tails curled up over their bodies virtually always. It's sort of like the tail of a chameleon, but it curls up instead of down. And the reason that it curls is actually a whole lot less obvious. Though it seems to have something to do with discouraging predators, or at least making the tail a more conspicuous target, as they do it more often when a predator is present than when one is not. The 23 or so species of curly-tailed lizards are all found in the Caribbean islands, and they are the most distantly related family in all of the Pleurodonta. It looks like they diverged away from the other members of the clade more than 90 million years ago during the Cretaceous. Which means that when the non-avian dinosaurs went extinct, the ancestors of curly-tailed lizards had already been on their own path for more than 20 million years. It also gives us an upper limit as to when the other groups would have diversified. Since this is the basal-most family, the rest have to have diversified since then. But 90 million years ago, the trip from the southern tip of South America to Madagascar was not nearly as long as it is today. In fact, I think there's a decent chance that the winds and currents could have taken something on a straight and comparatively way short path to Madagascar without ever going anywhere near Fiji. So I'm excited to see if this has anything to do with how the members of the Pleurodonta got there. But if the curly tail and smooth head aren't enough for you to identify curly-tailed lizards, then their overlapping scales and lack of femoral pores, these little pores on the upper legs along the femur of many lizard species, especially in males, well, they ain't got them. So 90 million years, that's when the hagfish of Pleurodontans broke away from the rest of the clade. The next most distantly related members of the Pleurodonta are probably the best known family in the clade. In fact, if you could name just one family in all of Iguania, it'd probably be this one, the family Iguanidae, which is a totally rad family that includes all sorts of iguanas. In the past, it included a whole lot of other groups as well. It was just honestly a garbage bin of pleurodontan lizards. And while many of these groups that were previously classified as iguanids are now classified as being, well, their closest relatives, there are still nearly 50 species of iguanas that I would call true iguanas in the family Iguanidae, including this little guy, which is probably the most surprising member of the family. It's pretty much the only one without iguana in its common name. Most people are surprised when I tell them that this lizard, the infamous chuckwalla, the only lizard known to frighten Chuck Norris, and a lizard not to be chucked with, lest you find out, or so I have read, is an iguana. Though they're much less surprised when I mention how much its head looks like that of a marine iguana. And while the chuckwalla is more closely related to marine iguanas than marine iguanas are to, say, desert iguanas, Cyclura iguanas, like rhinoceros iguanas, or the 4 species of Fijian iguanas, Their closest relatives are the two members of the genus Iguana. So the chuckwalla is firmly and unquestionably a true iguana, despite the fact that they lack the dorsal spines and dewlaps that are very common across the group. Hard to jam those things between rocks, though. They also lack the whip-like tail and super sharp claws present in many of the other members of the group. Now let me tell you, you think you know iguanas. Like, you probably know about green iguanas. But what about the other member of their genus, the lesser Antillean iguana? You probably know about marine iguanas and rock iguanas, perhaps desert iguanas. But have you ever seen one of these before? Or this? Iguanas are amazing. They really need their own video. But that last one, while it is called an iguana, is not actually part of the iguanidae. So just to reiterate, chuckwallas are totally iguanas, no question. But this, whatever it is not an iguana. At least, it's not an iguanid. And I don't think that chameleons are iguanas. I've never heard anybody claim that. Though I am frequently asked if my bearded dragons are iguanas, and they're no more iguanas than are chameleons. But unless chameleons are iguanas, then being in the iguania is not enough to call something an iguana. So I guess the question is, are all iguanas iguanids? Or is it possible that this thing is a true iguana too? Well, the 10 remaining families of pleurodontans are more closely related to one another than they are to the family Iguanidae. Which means that if iguana is a true iguana, which I assume that it is, and any member of these other 10 families, then all of the members of these other 10 families must be iguanas as well. And these 10 remaining families are nested in 2 major clades, one with 3 families and one with 7. And I'm super excited about both of them. But I'll start with the smaller clade because it contains lizards that can run on water, as well as this lizard that we found in Peru that I had never seen before in my life, the Amazon forest dragon, one of the 20 species in the family Hoplocercidae from Central and South America. These lizards are frequently called dwarf iguanas for reasons that seem perfectly reasonable, at least assuming that they are actually iguanas. They are relatively small but robust little lizards with strong vertebral crests. They are also often called wood lizards and even dragons, though dragon is usually reserved for the family Agamidae that we'll be discussing shortly. That said, they really remind me of mountain horn dragons. One species even has horns. They're just found on the wrong side of the world, and, well, their teeth are all wrong. Some have spiked tails, with the most extreme example found on the spiny weapon tail. I really like these lizards. And if I hadn't gone to the Amazon or made this video, I could have easily gone my whole life without ever even knowing that they existed. Good thing I did both of those things. The closest relatives of these dwarf iguanas are 2 of the coolest families of lizards anywhere. The family Crotophytidae, the collared lizards, and Corydophanidae, the basilisks. You tell me which one of these 2 is coolest. I'll start with the collared lizards because I recently learned something surprising about them. That isn't to say that it didn't make a ton of sense. I just never heard this before. So here in Utah, we have collared lizards. They are one of the coolest lizards in the state, and that's saying a lot. We have a ton of red lizards. Now, this is an unusual family in this clade, as it is found exclusively in North America, mostly in the desert, and is carnivorous with vertebrates making up a non-trivial portion of their diet. Not what you normally think of when you think of an iguana. They also have no spines or dewlaps or anything like that. And there are about 9 species of collared lizards in the genus Crotophytus. But what I didn't realize was that there is a second genus in the family. A genus of lizards that are also on my list of raddest lizards in Utah, the genus Gambelia, the 3 species of leopard lizards. I mean, in retrospect, they act and look basically like collared lizards. They just don't have a collar. And that is why molecular phylogenetics is so valuable. It is so easy to get hung up on something conspicuous to your subjective senses and totally overlook all of the other evidence that would have more accurately informed your understanding. Oh, and just because it's rad, crotophytid lizards often run on 2 legs, like Tyrannosaurus rex. You gotta admit that's rad. And something that they very much have in common with their closest relatives, the 11 species of basilisks, helmeted, and casqueted iguanas in the family Corytofanidae, found from Mexico to Ecuador. Which are only iguanas if collared lizards and leopard lizards are as well. Which isn't an obvious sell to me, but maybe they're just the oddballs of the group. Now, I don't know if you've ever seen a helmeted iguana before, but how cool is that? As a group, this family is all kind of wiry, fast-running lizards that generally can also run on 2 legs, and in some cases, right over the surface of water. There's even a great song about it if you ever get a chance to watch this video. They are generally great climbers that live in forests and often have elaborate crests on their heads, backs, and tails, especially in males. And they can't drop their tails. I like that about them. And that brings us to the larger clade of potential iguanas. And remember, for helmeted iguanas to be true iguanas, then not only do the dwarf iguanas and collared lizards need to be iguanas, but also everything in this other clade as well. Because all 10 of these families are more closely related to one another than they are to the iguanids. Now, the family most closely related to the other 6 in this second clade is the family Tropiduridae. Odds are that you have never heard of this family. But this thing, the glorious green thorny tail iguana, it's one. As are some of the coolest lizards that we found in Peru, such as the olive tree lizard and the collared tree lizard, and one of the lizards that I was most hoping to find during our adventure, the western leaf lizard, which we did find. And if you've never seen a tropidurid before, it's probably because you've never been to South America. Or you didn't spend nearly enough time wandering around looking for lizards. Because they are fairly common there, but are only found in South America and its associated islands like Trinidad and the Galapagos. Because it is difficult for eggs to incubate at high altitudes, the fact that many of the members of this family are live bearers has allowed them to be some of the few lizards that you find high in the Andes Mountains. They are found in desert locations, jungles, on islands, in the trees, and on the ground. Iguanids may be the most famous lizards in the Galapagos, but there are way more endemic tropidurids. The remaining 6 families in the Pleurodonta fall into 2 clades of 3 families each. And they are, altogether, the closest relatives of the Tropiduridae. And I don't know which clade we should discuss first. They both contain some rad iguanas, but this clade contains this lizard. This is a monkey anole, also called a forest iguana. But is that true? We've done a video on them in the past. We did find one in the Amazon. And while we're collectively trying to decide if it's actually an iguana, I have heard on many occasions that it isn't an anole. Well, that's reason enough for me to start there. Even though that will mean that we will have to wait a moment longer before we can find out how those dang Malagasy iguanas ever got to Madagascar. But don't worry, you'll be glad we started here, because the family least closely related to the other 2 in this clade is the family Phrynosomatidae. And this family is definitely going to need its own video in the future. It is also a family that I think really throws a wrench into the "these are all iguanas" narrative, because it contains things like this. Horned lizards, some of the most charismatic and grumpy looking lizards on the planet. And these, side-blotched lizards, which have 3 different types of males, just for the record, and a lot of other common lizards here in Utah, like these. And zebra-tailed lizards, which are the fastest lizards I have ever caught. They're just a blur. As well as earless lizards and California rock lizards that look a lot like collared lizards but with partially covered ears, fringe-toed lizards, and many more. It's a rad group of mostly desert lizards found primarily in North America, but as far south as Panama. About 170 total species. They're some of the most common lizards that I see, so I'm really looking forward to digging into them. And just for the record, I will never run out of incredible animals to show you guys. I will just eventually run out of life. So are horned lizards iguanas? While you're thinking about that, I will introduce you to the 2 families most closely related to the horned lizards and the other members of the family Phrynosomatidae. the family Polycrotidae, which is the family that includes this guy, and the family Dactyloidae, which are their closest relatives. Now, of course, for any of the other non-iguanids that we've been discussing to be iguanas, both of these families would need to be as well. So, what are they? Well, let's start with the monkey anole, which apparently is not an anole, but it is one of the 8 species in the family Polycrotidae, which are frequently called bush anoles. They're found in Central and South America, as well as many nearby islands. I can tell you that these are some seriously wonderful little lizards. And beautiful. They are very similar to anoles in many ways. They have a fairly similar body build, though their tails are probably a bit longer proportionally, and their face is a bit shorter, though still pointy. They have very similar eyes, which are a bit like those of chameleons, and they have very prominent flag-like dewlaps. It's not hard to see why they're often called anoles. That and the fact that their closest relatives are the anoles. The more than 425 species of unquestioned anoles in the family Dactyloidae are apparently the closest living relatives of the bush anoles, and vice versa. Not long ago, we discussed the fact that high-contrast Chinese bamboo bears are not pandas. And the reason that they are not pandas is because pandas, actual pandas, are much more closely related to all sorts of other things than they are to giant pandas. But if the closest relatives of pandas were these black and white bears, and vice versa, do you know what I think would be a totally reasonable name for them? Giant pandas. So are bush anoles actual anoles? I mean, they don't have to be. They're the hagfish of anoles. You can include them or not. But I'm certainly not going to correct anyone who calls a monkey anole from now on. Or a monkey anole, even though that's technically not the correct pronunciation. And that's even despite the fact that there's still some question about their relationship. But that's still not a panda. Slim Shady out. So let's talk about the unquestioned anoles. We found some beautiful anoles in Peru. I've found anoles in Alabama, Florida, and the Bahamas. You can probably name a few species, but as has been the case with many things here, that's just the tip of the iceberg. And there are well over 400 species in 8 genera, and they're found all over the warmer parts of the Americas. We definitely need to dive into this family in the future. I mean, just look at these. They can generally be identified by their long pointed faces, flag-like dewlaps, and gecko-like toes that allow them to cling to smooth surfaces. They're really special lizards. But the question is, of course, are they iguanas? And that gets us to the final 3 families in the Pleurodonta, and how some of the members of this clade managed to get to Madagascar. And the family most distantly related to the other 2 is the family Leolamidae, which is a family of beautiful lizards that you've probably never seen, at least before today, unless you live in South America. There are well over 300 species after all. They feed almost exclusively on fruits and vegetation. There were a lot of lizards unlike any I had previously seen that I caught when I lived in Mollendo, Peru, and on the island of Amantani. I didn't have any means of identifying them at the time, but I'm pretty sure that this is what they were. They're really common on the western coast of South America, and that's right where I was. And I will say, they were beautiful. I love them. But they aren't iguanas. I'm going to go ahead and say that all of the iguanas are in the Iguanidae. And all of their closest relatives are just iguana adjacent. And that includes the 2 closest relatives of the Leolamidae, the 34 species in the family Leosauridae of Central and South America, often called tree lizards, Patagonian lizards, fathead anoles, even though they aren't anoles, smooth steppe and big head iguanas, even though I'd say they aren't iguanas. But what they are really stocky, often big-headed, robust little lizards. And then the 8 species of Madagascan iguanas in the family Opleuridae, which are the ones we've been waiting to discuss. So all of these pleurodontan lizards have been from the Americas, except for the Fijian iguanas, which certifiably are iguanas, and these, which are not actually very closely related to the Fijian iguanas. And they live ridiculously far from both Fiji and the Americas. So how'd they get there? And when? Because the more recently this happened, the more insane this voyage becomes. Well, it appears that these Malagasy pleurodontans diversified from their closest American cousins about 60 million years ago. To my knowledge, we have no fossils of pleurodontans in Africa, though it is possible that they rafted to Africa and from Africa to Madagascar. That said, if it happened, there's no evidence of it. Similarly, they could have traveled to Antarctica, which at that time was not glaciated, and was full of South American taxa, as the two were in very close proximity. So they may have made their way up to Madagascar in a similar way to the way that marsupials got to Australia, though Australia was much closer to Antarctica than was Madagascar. We don't have many fossils from Antarctica for some reason, but this explanation, it doesn't even seem as likely as the Africa hypothesis. Honestly, the most likely explanation in my estimation is simply that they rafted directly from South America to Madagascar. It was at this time possible to travel in a straight line from South America to Madagascar, and given what ocean currents are like today, that seems very likely to have been what happened. Obviously, this is a pretty freak event, but we only have evidence that something like this has happened twice in the last 90 plus million years in the Pleurodonta. And I've got to tell you, you probably shouldn't buy lotto tickets. The chances that you will win are so small that it's just never going to happen. Well, not never. I mean, if you play every week for 90 million years, well, the odds that you will win a time or two are much more in your favor. So we have some pleurodontans in Madagascar, but they're not the only iguanians in Madagascar. Though I've never heard anybody call this an iguana. In fact, despite the fact that there are anoles called false chameleons, you're unlikely to confuse this with anything else. Chameleons are quite possibly the weirdest of all lizards. I mean, even snakes aren't that weird if you consider how many times leg loss and reduction has happened in Lepidosauria. But chameleons are delightfully bizarre. And almost half of the 200 or so species live in Madagascar, with the rest of them in and around Africa. However, to talk about them, we need to wander out of the Pleurodonta to the other clade of iguanian lizards, the Acrodonta. You know, the clade with the ossicone teeth. And while Acrodonta only contains 2 families, they are 2 absolutely amazing families, without a single species living in the Americas that wasn't introduced by humans. Both families are definitely weird and amazing enough to warrant their own videos. And the truth is that I don't know which family is cooler. I'm really gonna need your help deciding. So let's start with the chameleons of the family Chameleonidae. They're insane. Where do we start? Eyes, feet, tails, long tongues, or how tiny they can be? Let's just go in order. They have crazy eyes. Like these. Actually, more like these. We've seen similar eyes in groups like the 2 anole families. Their eyelids, top and bottom, are fused shut, with just a tiny opening through which the pupil can see. Their eyes can move independently of one another, allowing them to look in 2 very different directions all at the same time, and their brains can process that. And for their size, they have some of the best vision of any vertebrate. Visual acuity is based more on total eye size and not relative eye size, but they have the densest accumulation of cone cells in their eyes of any vertebrate on the planet. They are very visual, which is good because, like their cousins, the earless lizards, they have no external ears. They can hear, but like snakes, it isn't their strongest sense. And unlike snakes, smell isn't their strongest sense either. Their tongues are, well, otherwise occupied. But first, let's talk about their weird feet. They're seriously weird. That was one of the major flaws with our chameleon skeleton. Its feet were not nearly weird enough. Chameleons have 5 toes on each foot. That's not that weird. But they functionally have just 2. Oppositely oriented toes. Their bodies are laterally compressed, like a sunfish, where most lizards are dorsoventrally compressed, like a stingray. And on each foot, they have 1 toe bundle that faces towards the body and 1 that faces away from the body. On their front feet, the body side toe bundle has 3 toes. On their back feet, the away side toe bundle has 3 toes. And this is a spectacular arrangement for holding onto branches. But that isn't their only tool for holding on. Most species have long prehensile tails that curl the opposite direction to that of the curly-tailed lizards. And they can hold onto a branch, extend their bodies, and reach for other faraway branches. They aren't jumpers. In fact, they do nothing fast, and they don't tend to take leaps. The only thing they do quickly is grab their prey. Something they can do from great distances thanks to their incredible projectile tongues that we discussed in this video. Snout to vent length, or the length of the body without the tail, is a common measure of size in many animals. And the tongue of most larger chameleons is 150 to 200% of the snout to vent length. In smaller chameleons, it's even longer. I can't wait to go into more detail about this when we do a full video about chameleons. Now, I said that smaller chameleons have proportionally longer tongues than larger chameleons. And the truth is that chameleons can be exceptionally small. Like one of the smallest of all known vertebrates kind of small. I mean, look at that. They also change color, more to indicate mood than to blend in. And changing color to communicate is something that they very much share with many of their closest relatives in the family Agamidae, which may not be as weird, but what it lacks in weirdness, it makes up for in pure diversity. In many ways, the Agamids alone fill in Africa, Asia, Europe, Australia, and countless islands in between all of the roles that the 12 families of pleurodontan lizards work together to fill in the Americas. There are 550 agamid species, so it isn't that shocking, I guess. But let's just look at a slideshow of agamid lizards, often simply called dragons, for just a moment. I mean, you have fairly normal looking agamids that fill typical lizard roles. Basically the collared lizards of dragons, like the butterfly agamas and a ton of others. You have some anole-like agamids. The chuckwalla-like uromastics. The thorny devil is basically a horned lizard, except even more hardcore. Sailfin dragons kind of fill that large iguana role. And water dragons, that of the basilisk. I guess also maybe with the sailfin dragons. Plus there's some that fly, or at least fall with style. And toad-headed agamas are the lizard response to the sarcastic fringehead. Frilled dragons are cooler than dinosaurs, some would say. Forest and horned dragons look familiar. And that is just scratching the surface. We could spend a month in the Agamidae. And maybe someday we... And that completes our tour of the Lepidosauria. Happy Lepidosaur 2024. So which one was your favorite group? And what is a lizard? As always, like and subscribe. And we hope to see you real soon. If there has ever been a full dive through every family of the Lepidosauria ever done, I am certainly not aware of its existence. Like,
you should say, or ever will be.
Yeah. Isn't that wild?
Yeah, that's big. Well, rocking chairs.
Uh-huh.
There's a statistic on rocking chairs.
If anyone has ever been killed in a mishap with a rocking chair, that ties them.
That ties a rocking chair mishap.
Yes.
I'm sure it makes national news.
Can we Google the pronunciation? Anguimorpha. They're all members of the clade Anguimorpha. Oh, that's the word yes.
Yes.
And yes.
Use.
And yes. It also includes iguanas. Leiocephalidae. Leo? How do you say L-E-I-O? I before E except after C, or when it has another vowel and it's part of a 3-vowel chain preceding a C. Not directly before the C, but on the other side of an O that is then followed by a C. Then you go L-E-I, instead of L-I-E.
Yes, sure.
No further questions. Or when sounding like A is in neighbor and way. And on weekends and holidays and all throughout May, and you're wrong no matter what you say.
I wanted to make the...
Didn't know we were going to have a drag race.
Yeah.
They also have fracture planes in the tail vertebrae.
Hold on, we're going to show a bunch of anuses.
We're going to show a bunch of cloacas. The anus is inside of the cloaca.
Clint, how tall are you?
6'1"?
6'1"?
Mm-hmm.
No.
How tall am I supposed to be?
Really? 6'1"?
Yes.
Snout to vent?
Oh no, I'm much shorter. My snout to vent length is considerably shorter.
We should measure you with snout to vent.
Yeah.
You have a measuring tape? Where's one here?
I also like being measured in hands.
Yes, for some reason. Alright, bent over.
You can get me a snout to vent right here.
Would you say that's your vent right there?
And it's just snout.
No, so is that the...
Here, stretch your neck up. Yeah, there you go.
You are... Hold on. 34 inches.
34 inches.
Impressive.
Yeah.
Such a big boy.
Multiple list. Did you want me to do that again? Oh.
Yeah. No, sorry, there's a gnat bugging me.
It's not a bug. It's insecting you.
A gnat insect.
Yeah.
You should make that a thing.
Yes, I should. Well, but they still see.
They're kind of like the cool guys that come into a building and have their sunglasses on the whole time.
Indoors.
Indoors.
So here's what I'm going to make sure Karen knows. Is that if you're ever in an accident and it looks like you will have lost your vision, that you will want your eyes scooped out of your head.